Hello class, it is Tuesday, February 18th, and this is the lesson referring to the first day of 2.2 counting arrangements, focusing on permutations. We have already talked a little bit about permutations. We know, for instance, if we have something, let's say, like 3 factorial, that means 3 times 2 times 1, and it's equal to 6. We've used this when we find some kind of a product code, or we use these in our event blanks a lot. So when we talk about permutations in this section, what we're going to be talking about is order. And you'll read that first box. It says an ordered list of elements. 2 permutations are different unless they consist of exactly the same elements in exactly the same order. So order is the most important word there. Order does matter, repetition is not allowed. So an application of this, a very simple application, would be, let's say you have 3 pins and you want to know the different orders that you can align them on your desk. Well, that would be 3 factorial, 6 that we got from earlier, 6 ways to rearrange the pins on your desk. To avoid order, or sometimes a quicker way to get to your event blanks, there's this formula that I typically have students do by hand and by calculator. Since I'm not there this week, it'll strictly just be by calculator. So that might be challenging for me to try to explain over this, especially if you're using a phone. But if you have any questions, just make sure you're sending me a message. Just a brief demonstration of how this formula works. Let's say you were trying to figure out how many words, if you had 6 different letters, how many 4-letter words could you make? Now we say words, but if I can come up with any slew of 4 letters, I'm going to count that as a word. Whether it's phonetically or grammatically incorrect, that does not matter. So naturally, if I do event blanks like in the last chapter, I have 4 letters, and I have to pick from 6 the first time. But since they have to be different, I have to pick from 5 the next time, then 4, then 3. 360 words can be made. Let's see what we get when we use our formula. So that's going to be phrased as the permutation of n, which are the number of things, comma r, the number of things that you're trying to attain. Okay, so the permutation of 6 and 4 is equal to 6 factorial over, we say 6 minus 4, so that would be 2 factorial. Let's see, so 6 factorial we already know. Part of it, it's going to be 360. The only thing we're missing is the 2 and the 1. So if I can just double that, 6 factorial, use your calculator, it's very easy. 6 and then look for the exclamation button, you would get 720. And on bottom, 2 factorial is just 2 times 1. It's the only factorial that's equal to itself. So we end up with 360, just like we would have if we used the event blanks. I'm going to take you through some examples here, just getting used to that. Even though the calculator makes these a lot easier, these can all be done by hand. So I'll try to speak and go quickly. Part A is 5 factorial. 5 times 4 times 3 times 2 times 1. Answer is 120. The next one. Now, I think you get the idea that this is going to be 8 times 7 times 6 times 1, blah, 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 blah. That's a huge number. So the beauty of your calculator is if you just hit 8 and then the factorial button, it will just spit out the number, easy peasy, 40,320. Big number. Even bigger number, 30 factorial. You can imagine if 8 factorial is in the 40,000s, if we keep multiplying that by 9 and 10 all the way up to 30, that's going to get enormous. And your calculator might spit out an answer that looks something like this. This is what mine says. And this is a number that's in scientific notation. It means it's got 32 other zeros or place values that are not attached to this number, but it would make this number quite large if we kept moving that decimal place 32 times. So those are some of the things that can kind of get thrown your way. If you're using the arithmetic method and you don't have any calculator, I want to show you how to do that as well on letter D. You could do 7 factorial, write it out, you get 5040. On bottom, I would do these two individually. So 3 factorial would be 3 times 2 times 1, which is 6, and 4 times 3 times 2 times 1, which is 24. Then if you multiply these two numbers and divide, you would get 5040 divided by, let's see, that would be 4 carry 2, 12, 13, 14. And when we divide there, we get an answer of 35. Well, let's say the problem is posed to you in a different way. They want a permutation of 8. Let's say we go back to the example from before. That would be 8 letters, and we want to know how many 5-letter words we can make. Or we have 6 letters to choose from, and we want to know how many 2-letter words we can make. So this is utilizing your formula from above, which would be n factorial over 8 minus 5 factorial, which would be 3 factorial. So let's just go back up here. You need to subtract those two. And if I divide these out, I wind up with 4320 from before. And 3 times 2 times 1 is going to be 6 for a final answer of 6720. We got one more. Just practicing permutations. We have 6 factorial over 6 minus 2, or 4 factorial. Here's another quick way to do these if you have to do them by hand. I think there are calculators under my desk, but if you go and ask for one, make sure you return it. They are not mine. But you can knock out your 4s, your 3s, your 2s, your 1s, and you're just left with 6 times 5. And that's pretty easy to do in your head. So that's just 30. Okay. Okay, going through all this factorial stuff has taken us to about 7.5 minutes. So to speed this along, I'm going to go through these examples up to number 6. And if I feel like something's different, we'll definitely go through it. But other than that, I think these first few examples are much like what you've seen in the past. So let's go ahead and go to number 2.